Hi everyone, my name is Professor Rad, and today we're going to start discussing the idea of a common denominator. So we won't work on finding a common denominator quite yet, we'll save that for the future videos, but we're going to sort of lay the foundational work. So to begin, we're going to do a little experiment and just kind of play around with fractions a little bit to see, if we can develop a certain technique. So, for example, let's say you are having a pizza party. So you've got a pizza, and the pizza comes cut up into 6 pieces. All right. So, part of the problem maybe at your pizza party is that you don't have 6 people at your party. Let's say you've got 12 people at your party. And you're like, oh man, my pizza only has 6 pieces. So let's say I want to cut it up so that everybody can have a slice. So if I have 12 people coming, if I cut each of those slices in half, then I'm going to have 12 pieces. So I can say, yeah, everyone can have a slice of pizza, and nobody's going to know that they're having, that you cut it up into 12 slices instead of 6, that it didn't come that way originally. So we can see that if you have a fraction that's cut up in one way, like in 6, you can cut each of those slices up in another way to get a different denominator. So for example, let's say we had a pizza and it was originally cut up into 4 pieces. They just cut it like that for whatever reason. Well, if I have my 12 friends coming, I could take each of these quarters and cut the quarters up into thirds, into 3 pieces each, because 3 times 4 is also 12. So if I started with 4 pieces instead of with the 12 that I needed, I could cut each of those pieces up into 3, and then I would get my 12 pieces at the end. So what this will allow us to do is to essentially like unsimplify fractions or find equivalent fractions with different denominators. So for example, let's say I had that pizza and it was cut up into those 6 pieces to start. And let's say I ate one of those pieces. Let's eat more than that. Let's say I ate 2 pieces of pizza. I was really hungry. And then if I wanted to know, instead of out of 6 slices, if I had cut this up into 12 slices originally, how many of the 12 slices would I have eaten? So right now I've eaten 2/6 of my pizza. These I ate 2 out of the 6 slices. Instead, I want to know, what if it had been cut into 12 slices? How many of those 12ths would I have eaten? Well, we can do the same kind of idea that we did here. We took each of those 6ths and divided them in 2 pieces to get 12 total. So if I cut each of these pieces up into 2 slices each, now I have 12 slices in my pizza, and I ate 1, 2, 3, 4 pieces of them. So what this means is that 2/6 is the same as 4/12. Okay. Now, in this case, if I multiply 6 by 2, I get 12. And if I multiply 2 by 2, I get 4. Let's see if we have a similar kind of thing happening if we were originally divided into fourths. So let's say my pizza was cut into 4ths. And let's say I originally ate 2 of those pieces. Let's say I ate this piece over here and this piece down here. So I ate 2/4 of this pizza. And let's say I want to know, well, how many is that in 12ths? How many of the 12th sized pieces did I eat? So as before, when we were up here, we cut each quarter into 3 pieces. So I can do that here as well. Cut each piece up into 3 equal-sized pieces. And now we can count up how many pieces I ate total. So we had 1, 2, 3, 4, 5, 6. So that means that 2/4 is the same as 6/12. Also, we can notice if I do 4 times 3, I get 12. And if I do 2 times 3, I get 6. So what we're noticing here, there's some sort of pattern happening. Here I cut each piece up into 2 to go from 6 into 12. Here I cut each piece up into 3 to go from 4 into 12. Whatever I multiply that bottom number by in order to get from 6 to 12ths or from 4 to 12ths, I can also multiply the top number by to see how many pieces I ate. In other words, to go from 6 to 12, I multiplied by 2. So 2 times 2 gives me 4 pieces that I ate. And here, to go from 4th to 12ths, I multiplied by 3 because I broke each of these up into 3. And 2 times 3 gives me 6. So this is sort of a visual way of thinking about some of the techniques we're going to be developing. There's another way you can think about it as well. For example, let's say I think of the fraction 3/3. What would that fraction look like? Well, I have a chocolate bar or a pizza, something, and I cut it up into 3 pieces because the denominator is 3. Then, because the numerator is 3, fill in all of those pieces. So if I ate 3/3 of a candy bar, that would mean I ate 1 entire candy bar. And in fact, it didn't matter that I had thirds. If I had like 4 quarters, I would have eaten an entire pizza. Or if I had 12 out of 12, I ate all 12 pieces out of the 12 pieces. So one of the things that's kind of interesting about fractions is if you have the top number and the bottom number the same, it'll always equal 1. Except for 0, because 0 is the problem child. But if you have any other number, like 5 over 5, a million over a million, it's always going to equal 1. The reason 1 is an interesting number in this case is because if you take any number, for example 5, and you multiply it by 1, you get the number back again. So for instance, if I were to take 2/6 and I multiply by 1, I'm going to get 2/6 back again. I'm going to get the same value. So what we're going to try and do for our technique, if I want to change the denominator of the fraction, is I'm going to take that fraction, multiply it by a very special kind of 1, for instance, 2 over 2. Because I know if I multiply by 1, I'm not changing the amount, I'm just changing how many pieces it's cut up into. So the total piece that's shaded in is going to remain the same. And if I do 2 times 2, I get 4. And 6 times 2, I get 12. So this is a sort of more algebraic or arithmetic way of looking about, kind of more algebraic way of looking about getting a new denominator, whereas this is a more visual way that we can use to get there. So let's summarize all of this in a list of steps, and then we can work through some examples. Okay, so I've summarized the results of what we were just working on into some steps to help us work through some problems. So if we have a denominator we want to convert our fraction into, we can divide that desired denominator by the denominator that we have, and that's going to tell us how much to multiply by. So for example, if I had sixths and I wanted to get to twelfths, we cut each of those sixths in half in order to get to 12, since 6 times 2 is 12. Or when we had fourths and we wanted to get to twelfths, we would do 12 divided by 4 to get 3. And that tells us each of those pieces would have to be cut up into thirds. Then you're going to multiply the numerator and the denominator by that number to get your final answer. So I have 3 fractions here that we're going to write with the denominator of 24. So to do that, I'm going to start out by figuring out what I need to multiply by in order to get that denominator of 24. So for each of these problems, this is usually how I like to set them up to begin with. I need to multiply by a special version of 1 in order to convert to a fraction with this new denominator. Then what I'm going to do to figure out what goes here is I take the denominator I want and divide by the denominator I have. 24 divided by 3 is 8. This number is what I need to multiply by on both the top and the bottom. Then I'm going to do 8 times 2, and that will tell me the 16. So if I ate 2/3 of a pizza, that also means I ate 16/24 of the pizza. Okay, let's go ahead and do another one. So this time we're starting out with quarters. So we have 3/4. We're going to multiply that by something to get a denominator of 24. Why 24? Because that's what the problem wants us to use. So this will change with whichever problems you're looking at. So if I would like to write my fraction with a denominator of 24, I'm going to divide 24 by the denominator I have, which is 4. So we'll do 24 divided by 4, and that will give us 6. So 6 is the number I've got to put on top and on bottom. So that 4 times 6 is 24, and 3 times 6 is 18. So I get my 18/24. All right, let's do one more. So we want to write this one as well with a denominator of 24. So we're going to divide 24 by 16. So the other two, not too bad, because 3 went into 24 8 times, and 4 goes into 24 6 times. But now 16 doesn't go into 24. Hello, my old friend here. So it's actually okay. So what I'm going to do is I'm going to do, what's 24 divided by 16? It's 1.5, 1.5. So the cool thing is that you can have a decimal here. It doesn't have to be a whole number. So I could multiply the top by 1.5 and the bottom by 1.5. Because again, as long as it's not 0 over 0, this thing is always the same as 1, because 1.5 divided by 1.5 is 1. So it doesn't matter that it's a decimal. So to figure out the missing piece here, I'm going to do 14 times 1.5. I'm going to get 21. So 14/16 is the same as 21/24. All right, so here are a few problems for you to try on your own. This time you're going to write 5/9 with a denominator of 36, 13/18 with a denominator also of 36, and then 10/8 with a denominator of 20. In the next video, we're going to start to see why we might want to do this, other than if we just have more people than we expected at a party. So for example, if I rewrite things with different denominators, that's going to allow me to more easily tell which fraction is bigger than another one. It's also going to be enable me to compare, add pieces a little bit better. So if I ate one slice of pizza that was cut into 4 slices and one slice of pizza that was cut into 6 pieces, how much pizza did I have total, right? So if the denominators are different, if the sizes of the pizzas are different, I can rewrite them so that the sizes of the pizzas have sort of like an equivalent value, equivalent size, and that'll allow me to add those things more easily. So we're going to start building some techniques in the next video. And in the meantime, I hope you have a great day. Bye.